Alright, so once again, good day to each and every one of you. And for today's lesson is we will be discussing the part 2 of this chapter, which is all about temperature and heat. So for today's lesson, for the part 2 of temperature and heat, we will be discussing all about the quantity of heat. We have all about the calorimetry and phase changes, and also the mechanisms of heat transfer. So we will be discussing these 3 topics. Okay, so let's start with the quantity of heat or heat. So if we will define heat, heat is a form of energy transfer that occurs due to a temperature difference between a system and its surroundings. And also, it flows spontaneously from a region of higher temperature to a region of lower temperature until the thermal equilibrium is reached. Now, unlike work, which involves macroscopic forces and also displacement, now see heat, the heat transfer results from microscopic interactions. So again, if see work involves macroscopic forces and displacement, see heat transfer results from the microscopic interactions such as molecular collisions and also radiation. Okay, now as for the unit or the basic unit of heat, heat is measured in terms of joules, or joule if singular and then joules if plural. So, capital letter J ang basic unit ni heat or joules. And also, it can be transferred via conduction, convection, or even radiation. So, we will be discussing these three mechanisms. So, these 3 are the mechanisms of heat transfer. So, we will be discussing that later on. Okay, now here, what is the difference between heat and temperature? Okay, there are other instances na maka-question ta if unsa jud ay difference between heat and temperature. Now, when we say heat, it is the energy transfer due to the temperature difference. But when we say temperature, it is the measurement of the average kinetic energy of particles. So, the symbol for heat, we have capital letter Q, whereas for the temperature, we have capital letter T. And the unit for heat, we have joules. Unit for heat is in terms of degrees Celsius or degrees Fahrenheit, and also in terms of Kelvin. So, and what is the nature? Nature of heat is energy in transit, whereas the nature of temperature is just a property of a system. And the question here is, can it be stored? So see, heat, it cannot be stored, but it can only be transferred from one system to another. And as for temperature, yes, it can be stored as it describes the state of the system. And for the direction of heat, it flows from hot to cold. And for temperature, it indicates the degree. So the measurement magod of the hotness and coldness. So it indicates the degree of the hotness or coldness of a body or of an object. Okay. Now, when we say again temperature, it is the measure of thermal energy within a system, whereas see heat is the transfer of that energy from one system to another. So now we see the difference between temperature and heat. So again, when we say temperature, it is the measurement of thermal energy within a system, while heat is the transfer of that energy from one system to another. Okay? Klaro na ba? Okay. Now, let's go to the formula for the quantity of heat. How can we solve, or how can we calculate for the amount of heat transferred from one system to another? So we have here, that's what we call the heat formula, Q. Q stands for the heat is equal to M times C times delta T. Now, kinsa man ni sila? Okay, Q stands for the heat or quantity of heat. We have M is the mass of an object. We have our C is the specific heat. So specific heat. So each material has a different value for specific heat. So let's say for example for water, ang specific heat ni water is 4,184 or 4,186 joules per kilogram times Kelvin. So in other objects or in other materials, it has different value for specific heat depending on the material. And then delta T is the temperature difference. Temperature difference. Okay, temperature difference or the change in temperature. Okay, now how about their units? So the unit for heat, for Q, we have joule or joules. For M, we have kilogram. Basic units na sila. And then for C or the specific heat, we have joules per kilogram times Kelvin. Okay, Kelvin, capital letter K. And then for delta T, our unit that we will be using most of the time is in terms of Kelvin. Okay, now we have an example problem here. So we have here, this is for the quantity of heat. So how much heat energy is required to raise the temperature of a 2 kilogram water from 20 degrees Celsius to 80 degrees Celsius? So given the specific heat of water, which is 4,184 joules per kilogram times Kelvin. Okay, so let's write all the given values provided by the problem first. Okay, given. So the given are, the first one is the mass of the water, which is 2 kilograms. And then we have two different temperatures. Now the first temperature, can you see 20 degrees Celsius, is our initial temperature. Let's have it as T1, which is equal to 20 degrees Celsius. And then we have the final temperature, T2, is equal to 80 degrees Celsius. Also, we gitagaan po tag value sa specific heat sa water, which is 4184 joules per kilogram times Kelvin. Okay. Now, we are asked to solve for the heat required para mo raise ang temperature of this 2 kilogram water from 20 degrees Celsius to 80 degrees Celsius. Okay, so from the formula itself, or from the heat formula, Q is equal to M times C times delta T. So we have M, we have C, and also for delta T, by the way, when we say change in temperature or delta, ang formula gidana niya is the final temperature, T2, minus T1. So any change or any delta, ang formula gidana niya is final value minus initial value. Okay. So, we have right here 2 kilograms. Let's substitute the values times 4184 joules per kilogram times Kelvin times, we have T2 minus T1, or we have 80 degrees Celsius minus 20 degrees Celsius. Okay, so if you will calculate that one, this one here is, or we can also have it as 2 kilograms times 4184 joules per kilogram times Kelvin times, we have 80 minus 20 is 60 degrees Celsius. So our Q, by the way, before we proceed, as for delta T, we have this conversion from degrees Celsius to Kelvin. Now, this is only for delta T. Okay, when we say degrees Celsius to Kelvin, nga temperature conversion, lahi po to siya. So, for delta T, this is again for delta T, ha? Delta T is in terms of degrees Celsius. Now, if you want to convert that to Kelvin, this is not a temperature conversion nga typical nga plus 273 ha. This is another conversion. So, for the change in temperature, 1 Kelvin is equivalent to 1 degree Celsius. Again, this is only for delta T. So, if we will convert this one into Kelvin, so we can also have this one as 60 Kelvin. Okay. Para ma-cancel out si kilograms, ma-cancel out si Kelvin, and what is left is the unit joules for the quantity of heat. So if you will calculate that one, we have 2 times 4,184 times 60. The result will be 502,080 joules. Okay. So this is the amount of heat required para ma-raise ang atong temperature from 2 kilogram of water from 20 degrees Celsius to 80 degrees Celsius. Or the heat energy required is about 502 kilojoules. So we can also have it as 502 kilojoules. Kilo is times 1,000. So 502,080 joules. Okay. So that is for example problem number 1. Now, let's go to calorimetry. Now, when we say calorimetry, it is the science of measuring heat transfer during physical and chemical processes. Now, it is based on the principle of conservation of energy. Diba? Conservation of energy states that energy cannot be created nor destroyed. So, it can only be transferred from one system to another. So, in a calorimetry experiment, the heat lost by one substance is gained by the other or another system, ensuring that the total energy within an isolated system remains constant. So, we have the formula for this principle of conservation of energy, heat energy. So, we have Q lost or the heat lost plus the heat na gain must be equal to 0. Okay. Or, we can also substitute it as M1 times C1 times delta T1 is equal to the negative of M2 times C2 times delta T2. Okay. Now, how is calorimetry used to measure heat changes? Now, number 1, it determines the mass of the substances involved. Next is it measures the initial and the final temperatures using a thermometer, and also it calculates the heat transfer using the heat formula Q is equal to MC delta T. And then it applies the conservation of energy principle to find the unknown values. Okay, so example problem number 2. This is for the measuring the heat change in water. Okay, so we have here a 100 grams sample of metal at 80 degrees Celsius is placed in a 200 gram of water at 25 degrees Celsius. So the final equilibrium temperature is equal to 30 degrees Celsius. Now, if the specific heat of water is 4,184 joules per kilogram times Kelvin, find the specific heat capacity of the metal. Okay. Now, before we proceed, we will first identify the given values. So, maging ang pinaka-first step before we proceed in solving this problem. Now, we have first given is the mass of the metal, M sub M for mass of the metal, which is 100 grams. Or if you will convert that to kilogram, kay basic unit man atong gamiton, it is 0.1 kilogram. And also we have the initial temperature of the metal is at 80 degrees Celsius. Okay. And then we also have the mass of the water m sub w, which is equal to 200 grams, or it is equivalent to 0.2 kilogram. And this is for the metal, and then the initial temperature for water is at 25 degrees Celsius. Okay, and then we also have the final equilibrium temperature, T2. T2 is 30 degrees Celsius, and then we have the specific heat of water is 4,184 joules per kilogram times Kelvin. Okay, so those are the following given. Kani si T2 is the temperature na of the system nga naa na si metal gibutang nato sa 200 grams of water. Okay, so now using the equation or the heat balance equation, we have katong Q lost plus Q gained is equal to 0, or we can also have it as mass of the metal times specific heat of the metal times delta T of the metal is equal to the negative of mass of water times specific heat of water times delta T of water. Okay. So, ang ato ang target is to get the specific heat, C sub m, or the specific heat of the metal. Okay. So, what should we do? We will divide both sides. Before we substitute their corresponding given values, we will divide both sides with m sub m and delta T sub m. Para makancel out ni siya. So, ang mabili na lang sa left side sa ito equation is si C sub m is equal to the negative of mass of water times specific heat of water times delta T of water divided by mass of the metal times the delta T of the metal. Okay. So, let's substitute na dayon the values. We have negative of mass of water is 0.2 kilograms times specific heat of water is 4184 joules per kilogram times Kelvin times delta T. Our delta T is 30 degrees Celsius minus 25 degrees Celsius. And then divided by mass of the metal is 0.1 kilogram times delta T of the metal, which is 30 degrees Celsius minus 80 degrees Celsius. Okay. So, this one is negative 50. So, as you can see, we have also a negative here. So, the specific heat of our metal is a positive value. So, if we will calculate this one, C sub m is equal to 836.8 joules per kilogram times Kelvin. So, this is the specific heat of our metal. So, using the heat balance equation, or the Q lost plus Q gain is equal to 0, we got the value of the specific heat of the metal again, which is equal to 836.8 joules per kilogram times Kelvin. Okay, so that's it for the calorimetry. Now, let's proceed to the latent heat and phase changes. So, we are still on the calorimetry. So, latent heat and phase changes. So, when we say latent heat, it is the amount of energy absorbed or released by a substance during a phase change without changing its temperature. Now, we will talk about phase change later. So, latent heat is used to break or form molecular bonds during the phase transitions. So, the formula of latent heat is, we have this one, Q is equal to M times L. Okay, where M is the mass and L is for the latent heat. Okay, so there are three types of latent heat. Latent heat of fusion, we have latent heat of vaporization, and latent heat of sublimation. So number one, latent heat of fusion. It is the heat energy required to melt a solid into liquid. So ang ato ang phase change is from solid to liquid. Or it can also be liquid to solid. So reversible siya nga process. Okay, so an example for this one is an ice melting into water at 0 degrees Celsius requires 334 kilojoules per kilogram. And number two, we also have the latent heat of vaporization. So it is also the heat energy required to convert a liquid into gas. So evaporation, this is evaporation. So, liquid to gas. Kung si latent heat of fusion, it is solid to liquid or liquid to solid. Si vaporization is from liquid to gas. So, an example for this one, we have the water boiling into steam. So, from water, liquid, into steam, which is a gas, at 100 degrees Celsius, it requires 2,260 kilojoules per kilogram. Okay, so here are the following, actually daghan siya nga phase change. So, duha lang to ang akong gimension. So, we have the melting, the freezing, vaporization, condensation, sublimation, and deposition. So, these are the processes. Sa melting, we have solid to liquid. Freezing is liquid to solid. Vaporization is liquid to gas. And if atong balihon, it becomes condensation or from gas to liquid. And then we also have sublimation is from solid to gas, and deposition is gas to solid. So, sa melting, heat is absorbed. Freezing is heat is released. For the vaporization, the heat is absorbed, whereas condensation is heat is released. And sublimation, heat is absorbed. And for deposition, the heat is released. So here are also the following examples for each of the phase change. Okay, so another example calculation for the latent heat. So, question here is how much heat is needed to convert 0.5 kilogram of ice at 0 degrees Celsius into water at 0 degrees Celsius. So, the latent heat of fusion of ice is 334,000 joules per kilogram. Okay, so, given, let's write the given values first. Okay. So, the given values are, we have the mass of the ice is 0.5 kilograms. And then we have the latent heat of ice, which is equal to 334,000 joules per kilogram. Okay. Now, formula for the latent heat, diba, is Q is equal to M times L. Or in this case, this is latent heat of fusion, or L sub F. Okay, so we have mass is 0.5 kilograms times 334,000 joules per kilogram. So, makancel out si kilograms. And then, multiply 0.5 by 334,000, the result will be equal to 160,000 joules, or ang ato ang Q is 167 kilojoules. So that is the amount of heat that is needed if we want to convert 0.5 kilogram of ice into water. Okay. So, that is an example for the latent heat. Now, let's talk about the mechanisms of heat transfer. Number one is conduction. We have three: conduction, convection, and radiation. So, let's talk about conduction first. Okay. Now, conduction is the heat transfer through a direct contact. Now, the definition of conduction is the transfer of heat through a solid or between objects in direct contact due to molecular collisions. Na ang mechanism ni conduction is, it is the faster moving or the hotter molecules transfer energy to slower moving or the cooler molecules without bulk movement of the substance. And then, naabay kailangan nga medium nga required? Yes, of course. It occurs best in solids, especially on metals. Okay, so examples of conduction, we have a metal spoon heating up when placed in a hot pot of soup, and we have the heat traveling through a copper rod. Now, we have the formula for conduction. So, we have Q. Q is the heat transfer. Q is equal to K times A. Now, si K is the thermal conductivity. Thermal conductivity. A is the cross-sectional area. Cross-sectional area. And then we have T2 minus T1, or the initial and final temperatures. So T1 and T2 are the temperatures. So T1 is the initial, T2 is the final temperature. And then we have small letter T is the time, and D is the thickness. D is the thickness of the material. Okay. So here, muna siya ang formula for the conduction. Now, let's go to convection. Convection is the heat transfer through fluid motion. So, convection is the transfer of heat through the movement of fluids. So, it can be liquids or gases due to the differences in temperature and density. Now, the mechanism of convection, what happens here during convection is the warmer fluid expands, it becomes less dense and rises, while the cooler fluid contracts, it becomes denser and sinks, creating a convection current. So, do we need a medium? Yes, we need a medium, or medium is required because it occurs in liquids and gases. So, we have two types of convection. We have the natural convection and the forced convection. So, sa natural convection, it is caused by density differences. Example is warm air rising and also cool air sinking. Whereas for the forced convection, it is caused by an external force like a fan or a pump. So, for example, air conditioning or even the radiator. Okay, so we have the formula for convection. Q is equal to H times A times the difference of TS and TF. Now, si Q again is the heat transfer. We have H is the convection heat transfer. Coefficient. Okay. And then we have our A is the surface area. And then we have our TS is the surface temperature. So S stands for surface. And then our TF is the fluid temperature. Okay, TS is for the surface temperature, TF is for the fluid temperature. Okay, and then for the third one, we have the radiation. So, si radiation is the heat transfer through electromagnetic waves. Okay, so the definition, radiation is the transfer of heat through electromagnetic waves or infrared radiation without requiring a medium. So, what is the mechanism of radiation? So, the heat energy is emitted in the form of thermal radiation, and also it can travel through a vacuum. So do we need a medium or require ba any medium? No, because it can occur in space. So for example, sunlight reaching the earth. So no need for medium. So example is the heat from the sun warming the earth and feeling warmth from a fire without touching it. So again, wala na. As for radiation, there is no need for a medium or dili na required ang medium because it can reach or it can occur even in space. So, pwede ra nga baski walay medium, it can travel. It's because radiation is a transfer of heat through the electromagnetic waves. Okay. Now, the formula of radiation, we have Q is equal to, this one right here is our Stefan Boltzmann constant. Okay, so Q again is the heat transfer. This one, I forgot the term for that variable. This is Stefan Boltzmann constant. So, and also we have A is our surface area, and our E is the emissivity. Sorry, this is E, emissivity. So it ranges from 0 to 1. It depends on the material. And then for the T to the fourth, or T is the absolute temperature. Okay. So those are the three mechanisms of heat transfer. Again, we have the conduction, the convection, and the radiation. So here are the properties of it. We need medium, the mechanism, the speed of transfer, and some examples. So kindly look at the table for each of the mechanisms or the properties for each mechanisms of heat transfer. Okay. Now the applications. Let's go to the applications. Now for conduction, we have the first one is cooking on a stove. So when a metal pan manggod is placed on a stove, the heat conducts from the hot burner to the pan and then to the food. So nganong conduction man? Nganong conduction man ni siyang application? It's because metal is a good conductor. So it allows the heat to transfer efficiently. Now second one, we have the home insulation. So man nato sa cooking on a stove, we have home insulation. So the houses use insulating materials. Let's say for example fiberglass. We also use foam for our bed and even wood to reduce conduction of heat in winter and keep interiors warm. So kaning sa foam here in the Philippines is dili kinato na siya ginagamit. So mostly sa US or in other countries ginabutangan nila in between sa ilaang wall, sa sulod sa wall na ginabutangan nila og foam. It is to reduce the conduction of heat and to keep the interiors warm. So that is for the home insulation. So nganong conduction man ni siya nga application? So because insulators have low thermal conductivity, so it prevents heat loss. Okay. And then the third one, we have the car engine cooling system. So di ba ang components man gid sa engine is mostly metal. So metal components of an engine conduct heat from the combustion chamber to the cooling system to prevent overheating. So nganong conduction? Why conduction? So because the heat moves from high temperature engine parts to the coolant. Okay, so those are the sum of the applications or the three applications for conduction. Now let's go to the applications for convection. We have three also. We have the ocean currents and weather patterns, we have boiling water, and we have room heating for the radiators and air conditioners. Now let's start to the ocean currents and weather patterns. So the warm water from the equator rises and moves toward the colder regions, while cold water sinks. It creates convection currents. So, anong convection? So, the differences in temperature and density will drive the movement of water and air, influencing the climate. Okay, so that's why we have the weather patterns. Now, as for the boiling water, second one, boiling water. So, when heating water in a pot, ang bottom layer sa pot warms. It expands and rises while the cooler water sinks, also forming a convection current. So, nganong convection man? So, the heat transfer occurs through the movement of the fluid molecules. Okay, and then we have the third one, the room heating. So, this is for the air conditioners and radiators. Now, for the radiators, the radiators heat air, causing warm air to rise and cooler air to sink, now creating again a convection cycle. Now for the air conditioners push cool air down, forcing the warm air up to be para mabugnaw siya. So why convection? So the fluids or the air move due to the temperature and density differences. Okay. And then we have the applications of radiation. We have number one, sun heating the earth. We have the microwave ovens and the fireplaces and campfires. Now, for the sun heating the earth, so di ba ang sun, mag-emit man na siya infrared radiation. Nga mo travel gina siya from space and then it also warms the earth. So, nganong radiation, di ba? No medium is required. Ang heat is ma-transfer via electromagnetic waves. Now, microwave ovens. So, manata sa sun heating the earth. Now, we go to the microwave ovens. Now, microwaves, diba, again, uses radiation to excite the water molecules in food, causing them to heat up. So, radiation is because the heat energy is transferred again into electromagnetic waves. No, maski walay direct contact. And then, for the third one, we have the fireplaces and campfires. So, di ba, when you sit near a fire or sa kanang mga campfires, you feel warmth even without touching the flames. So, because the infrared radiation transfers heat through space. So, maski layo ka or dili ni mo ibutang imong kamot sa fire, you still feel the warmth even without touching the flames. So those are the applications for radiation. So I think that's it for our discussion for today. So I hope you've learned a lot on this lesson or the part 2 for temperature and heat. And also, we'll see you again on our next video discussion. Thank you so much for listening.